Once again to DevOps Lagos. My name is Emiola Idowu. I am a DevOps engineer at Demos. Today I'll be speaking about an introduction to Kubernetes. So let's get started right away. What is Kubernetes? Kubernetes is an open source container orchestration system for automating deployment, scaling, and management of containerized application. So when you go online and you search for Kubernetes, this is most likely the definition you're going to see. But the question now is, what exactly does that even mean? What exactly does an open source container orchestration system even mean? So let's take a few steps backwards. Let's talk about containers. Now, in the good old days, when you want to deploy an application, say you want to deploy a Node.js application that is interacting with MongoDB and Redis and RabbitMQ, your setup will be something similar to this, where you have to worry about the infrastructure, the underlying hardware. You have to also worry about the operating system. You have to worry about the libraries and the dependencies of each of these technologies. This leads to a compatibility L in such a way that for every technology you want to use and every technology you want to add on, you have to worry about a lot of other things that come with that technology you're using. The advent of containers, Docker, which is the most popular one, you only need you can isolate these libraries and dependencies of each of these technologies, give them different versions of libraries, different versions of dependencies, and they are all running on a common technology called Docker. Docker then sits on the operating system, whatever operating system, Windows, Ubuntu, any operating system, and you don't really need to worry yourself about the underlying infrastructure. So let's talk for a little bit more about containers and how it affects the topic of today. A container can be said to be a virtual machine, but instead of running in a predefined operating system, they run using your defined operating system in such a way that in a container you define the operating system that is going to be running within. As compared to a virtual machine that already has an operating system in it, and switching is a lot of technical overhead. Let's do a little bit of comparison between a container and an ideal virtual machine. So when you look at this diagram, you will notice that for a virtual machine, you have increased CPU utilization, you have increased disk space, increased boot time. That is, the boot time of a virtual machine is on the increasing side as compared to a container where you have reduced CPU utilization because you are running like a minified version of a virtual machine, and the disk space contained for an image, for instance a Docker image, is very small, and the boot time, since like I said earlier, it's a minified version, so you expect the boot time to be way less compared to a virtual machine. Now we've talked about containers, we've talked about a little bit comparison between containers and virtual machines. Now, what next? How do we run a container in production? How do we trust a container? What if our container depends on other containers? How do we manage that? When the number of users increase, when the number of traffic increases, how do we scale up or down our container? What if the container crashes? How do we spin up one immediately? So these are the questions we are going to be answering for the next 40 to 30 minutes, 30 to 40 minutes. Now this leads us to container orchestration. So let's revisit this definition again. Kubernetes is an open source container orchestration system. We've talked about containers. We're going to be talking about the orchestration part pretty soon. So Kubernetes is an open source container orchestration system for automating deployment, scaling, and management of containerized application. So let's dig deep into some of the basic concept of Kubernetes. One, a node. When you get familiar with Kubernetes, you are going to be hearing terms like nodes. A node is a virtual machine. It could be physical, but most often than not, it's a virtual machine which several Kubernetes components are installed in. And we have two types of nodes. We're going to be talking about the second type of node in a bit, but a node in general is just a virtual machine which several components of the Kubernetes itself runs on. So now let's worry about what if. So we're looking at the worst case scenario. What if a node fails? What if for some reasons, due to memory spike, due to CPU spike, a node crashes and you don't have access to that node? That leads us to what is called a cluster. In Kubernetes, you deal with a cluster of nodes in such a way that Kubernetes manages several nodes. For best practices, 3 nodes, in such a way that if one crashes for whatever reason, you still have 2 nodes serving the services running on Kubernetes. And based on the configuration, if you're using a cloud provider, based on your configuration, a new node is being triggered to replace the faulty node. Now, how does Kubernetes know when a node is down? How does Kubernetes know when to spin up another node? How does Kubernetes know to install components in the new node? That leads us to a master node. So in Kubernetes, we have the worker nodes and the master nodes. So worker nodes are nodes that basically run the applications, run your services, run your Node.js application, run your PHP application, and so on, while a master node is like the man in charge. It controls every other thing happening in the cluster. It controls the nodes, controls scheduling, controls every other thing happening in the cluster. Now, that kind of gives us, from the infrastructure side of things, that kind of gives us an introduction to the basic concept of Kubernetes. Now, let's pretty much talk about pods. Now, you must have heard, if you had Googled Kubernetes before, you must have heard about pods. Pods is a single instance of an application. It's the smallest thing you can talk about when you're talking about Kubernetes. It's the smallest object that can be created in the Kubernetes cluster. A pod is similar to a container. However, it does much more than just a container in the Kubernetes context. So let's look at a simple YAML configuration for a pod. So for a pod, you have a simple YAML configuration like this. You have on line 1, you have the API version. Basically, the API version is the version that contains the object you want to deploy. The Kubernetes version that contains the object you want to deploy. In this case, line 2, you want to deploy a pod. So line 3 to 6 talks about the metadata of the pod. That's the characteristics of that pod. You have a label. A label is very, very important in the Kubernetes cluster. Regardless of the components you are deploying, a label is very, very important. It is used to identify resources within the Kubernetes cluster. Then you have on line 7, you have the name of the pod, and from line 8 to line 11, you have the specifications of this pod, the image you want to run, the name, the container image you want to run, and the name of the container you want to run. This is a simple configuration of a pod to be deployed on Kubernetes. If we have time, we're going to be doing a simple demo concerning this. So we've talked about pods. Let's now worry about when the pod fails. Just like a container, a pod can fail for whatever reason. A pod can crash or for whatever reason, memory, CPU, for whatever reason, a pod could die. So how do we manage that? Then we start talking about a replica set. So the purpose of a replica set is to maintain a stable set of replica pods, that is similar instance of an application, replica pods running at every given time. So in your replica set, when you said, okay, I want a desired state to be 2, I want 2 pods to be running at every given time, the job of a replica set is to ensure that at every given time you have 2 pods running, whatever the case. So we're going to be looking at a simple YAML file for a replica set. Now, for a replica set, you have something like this. You have line 1, you have the API version, which I've talked about when we saw the YAML file for pods. And then on line 2, we have the kind. That's the kind of resource you want to deploy. That in this case, we want to deploy a replica set. A very interesting part is on line 9, where you specify the replicas. In this case, replicas is 3. That is, at every given point in time, I want 3 instances of my application to be running. I want 3 pods to be running in the Kubernetes cluster. Now, another interesting part is line 10 to line 13. So the selector. So the selector is very important in the sense that that is what the replica set used to identify the pods that belongs to it. So any pod that matches the label, that's on line 11 now, that matches the label app equals hello world, tier equals demo, belongs to this replica set. So this replica set manages it. This replica checks if it checks periodically if the number of desired, if the desired number of pod is equals to what is set in the configuration file. Now, if you look at between line 15 to line 22, you will notice that that is similar to the configuration set for a pod. That's the comparison we're doing here. That's the comparison we're doing here. So if you look at the configuration from the metadata part, you see that it's very, very similar to, in fact, it's exactly the same as the pod. So that's the template it used. So if a pod crashes for whatever reason, that's the template you use to generate another pod. So that's the function of a replica set. Moving on. Now let's look at a scenario where you want to upgrade your application. You want to upgrade, maybe you made a change, you made a commit to GitHub, and you want to push this change to Kubernetes cluster. Now you have the version 1 of an application. You want to move to version 2 of that same application. Now you have to worry about an upgrade. That's upgrading your new Docker image. You also, if you have several replicas, you also want to worry about a rolling update in such a way that you don't get to delete all the pods at the same time. You have to delete one, replace with the new version, delete the second one, replace with the new version, delete the another one, replace with the new version. That's a rolling update. Now, take for instance, you roll out the version 2 and you notice a bug. How do you roll back to version 1? A Kubernetes result that helps with this is the deployment. So the deployment sits higher in the hierarchy for pods and replicas, a replica set, in such a way that it helps with upgrade, helps with the rolling update, and it also helps with a rollback if anything happens. So deployment it provides us with capability to upgrade the underlying application instance seamlessly. So like I've mentioned here, it helps with upgrade from one version to the other. It helps with an rolling update, so such that we can expect low downtime or no downtime, and it can also help with rollback. So that's what a deployment helps with. Let's take a quick look at the YAML configuration for a deployment. Now, for a deployment, it's way more complex, and so because it does a lot of things. So if we look at this YAML file carefully, you will see that from line 1 to line 7 is pretty much similar to what we have seen so far, but the interesting part starts from line 9, where we have the replicas equals 3, which is very, very similar to what we saw in the replica set, the configuration for the replica set. Now, line 10 to line 14 talks about a strategy. That is, how do you want to update applications? How do you want to configure your upgrade? In this case, we have a type of rolling update in such a way that you have a max surge of 1. So you pick one pod, upgrade that. When you're done and it's in the ready state, you pick the next pod and you do an upgrade also. So that's the configuration we just set with this strategy. Now we also have the selector here on line 15, which is similar to what we saw in the replica set. So the deployment uses this selector to target the pods that belongs to it. So similar to a replica set, also we have the template where we can actually configure everything that looks that looks like a pod in such a way that this is a template that is used to spin up a pod when necessary. You can also configure your environment variables. You can specify the name of the container, the name of the image you're running, and you can also specify the port that your application is running on. So these are more at the configuration you can set in a deployment. Now, let's talk about communication between pods. Now, You have port A, port A in this sense, you could say port A is a Node.js application, and port B is a MongoDB application, is a MongoDB instance deployed on Kubernetes. You want a communication between these two ports. How do you achieve that? You have to then talk about a Kubernetes resource called a service. A service enables communication between pods, and it also enables communication between a pod and the outside world. So we'll look at the type of services that can allow that in a bit. However, a service is a Kubernetes object that enables communication between various deployments or pods within the cluster. And it can also, depending on your configuration, it can also help enable communication between the application running in the Kubernetes cluster and a user, or the outside world, that is outside the Kubernetes cluster. We're going to be looking at the YAML file for a configuration for a service, YAML configuration for a service, and we're going to look at the types of services that can enable each individual communication. Now, for a service, we also have to set the API version. We have to set the kind, that's service in this case. The name and labels go under the metadata. Now, the interesting part about this is the selector. So the service uses the selector to target the pods to route traffic to. That's why the label is very important when it comes to Kubernetes. So the service uses the selector. That's in this case we have two selectors: app hello world tier equals demo, to target the pods to route traffic to. Now on line 9, you're talking about the load balancer. The type of service, in this case load balancer in the sense that you can use this to access the application outside the Kubernetes cluster. Then you have other types, the node port and the cluster IP. The node port, the cluster IP, you can use it to access the pod within the cluster, and the node port actually gives you a port on the node the pod is deployed on. I hope that makes sense. So moving on from line 10 to line 12, you are talking about the port. So a very interesting part is this, because in this configuration means that if you have a type load balancer, users will access the port 80. However, the request will be directed to port 8080 on the pod, on the application that you want to route to. That's the configuration here. The port is what the users access. The target port is the port on the application you want to route traffic to. Yeah, so we've talked about communications within pod. We've talked about pod. We talked about replica set, and we talked about the big boss deployment. We also talked about the communication between pods in the Kubernetes cluster. Let's digress a little bit into what is called an ingress. An ingress is an API object that manages external access to services in the Kubernetes cluster. So basically, an ingress specializes in external communication with the cluster, external communication to your application that's in the cluster. So most times you could actually configure an ingress to accept HTTP traffic or SSL traffic. So it acts like a smart router that routes to different services depending on the domain configured. It can be considered as a smart load balancer. So we're going to be looking at all these dynamics in a bit. So I've mentioned load balancer a couple of times. So let's talk about load balancer for a bit. A load balancer helps to efficiently distribute incoming traffic, network traffic, across multiple instances of an application server. So it basically helps to balance traffic between several applications running in a virtual machine. So without a load balancer, you have something like this: a user on the internet accesses your application and goes straight to your application. So if you have 1 million users, 1 million users go straight to that same application, which can cause a lot of CPU spikes and crashing the server eventually. However, with the load balancer, you have something like this: user on the internet wants to access your application, accessing your application via a load balancer that has several instances of that same application behind it. So the user over the internet accesses this load balancer. Load balancer balances traffic based on based on its algorithm, balances traffic, equal traffic across all the instances of the application you have. So that's the function of a load balancer. However, in contrast to an ingress can actually achieve this based on the domain you specify. So in this configuration now, what we are saying here is we are saying if you visit test.example.com, you want to route to a particular service, which in turn routes to a particular set of applications. If you go to example.com/API, you want to route to another service, which in turn routes to several applications. If you go to example.com/videos, you want to route to a different video service, for instance, and you want to in turn route to the application underneath that. And if you go to another domain, you want to go to another service and another application. So that's what an ingress helps with. Based on the traffic and the domain configured, you get a different service. However, as compared to a load balancer, traffic coming into the singular load balancer goes straight to one service, yes, and in turn gets to communicate with several applications under that service. That's the simple comparison between a load balancer and an ingress controller and an ingress. However, to deploy an ingress to the Kubernetes cluster, you have to deploy an ingress controller. You have several ingress controllers, open source ingress controller. We have Nginx, we have Kong, we have Traffic, and cloud provider also have their built-in ingress controllers that come with the Kubernetes cluster. However, I'll be focusing on the components of Kubernetes in this case. So we've talked about ingress, we've talked about that in comparison with load balancer. Let's take a quick look at a simple YAML configuration for an ingress. So we have two types when it comes to YAML configuration for an ingress. We have the path route type and the host name type. So in this case, we are saying mydomain.com/API should route to the API service on port 4200, and /videos should route to the video service on port 8080. That's this configuration. And for this configuration, what we are saying is full.mydomain.com should route to service 1 on port 80, and bar.mydomain.com should route to service 2 on port 80. The configuration you use in this case depends on your use case, depend on what you are trying to achieve. So no one is better than the other. Moving on, let's talk about how we are going to undo configurations between deployments, how we are going to undo configurations and secrets within the Kubernetes cluster. So let's quickly talk about config maps. Config maps are used to pass configuration data in form of key value pairs. So if you look at let me give you a simple example. Say you want to deploy 10 microservices, and all these microservices connect to a singular MongoDB instance deployed on Kubernetes, for instance, or deployed outside Kubernetes. So you don't want to go ahead into every deployment YAML file and set MongoDB host equals this, username equals this and this. You can actually pack up all this configuration in key value pairs into the config map, and every deployment can actually inherit from that config map. Now, one of the major things this helps you to do is that you have one singular place to change your config in the future, and you have one singular place to manage. So take, for instance, you want to migrate from MongoDB to say another DB, and you want to change the environment variables. You don't have to go through all the 10 applications or more that you have. You can just change it in the config map, and those changes will be picked up when the pods are being updated. So that's one powerful thing about a config map. You could use a singular config across several applications. So a simple configuration for a config map is something like this. You have the API version, you have which is version 1. You have the kind config map. In this case, you have the name of the config map, and the interesting part is the data. So you have the key, in this case language equals JS, and website, which is also another key, equals jsremoteconf.com. So with this configuration now, this configuration can actually be inherited in several applications, several pods, several applications, and several deployments can actually inherit from this config map. Now we might be wondering that, okay, this is exposed. Can I get something more encoded, or to save my password or things like that? So we're going to talk about secrets. Secret is used to store sensitive information. As much as this is portrayed, it's not advisable to save this in a public domain. We're going to be talking about that further in a bit. So secrets are used to store sensitive information like password or keys, tokens, and things like that. They are similar to config map, except that they are stored in an encoded or hashed format. So basically, secrets are basis for encoded. So since this is a general knowledge, it's not advisable to encode this and then probably push to GitHub. It's not advisable because since everyone knows it's basically encoded, it can be easily decoded at any point in time. So it's just, so if you must use a secret, it's not advisable to commit it to a version control. So a simple configuration for a secret in this case is something like this. So similar to the config map, you have the data part. You have the data where the username is 64 encoded string, and this is the process of encoding it. So in this case, you have admin, and password in this case is also mapped to a base 64 encoded string, which is encoded with this also. So as much as this in code is safe, you also, since it's the general knowledge of how it is encoded and can easily be decoded by anyone, it's not advisable to commit this to a version control. So you could use several, you could actually use several external tools to manage your secret. You could look into Vault. You even use AWS parameter store and things like that. You could actually use to manage your configurations that you actually want to, that are sensitive, that you actually want to take care of. Now, in summary, we've talked about the compatibility L. We've talked a little bit about containers. We've talked about containers versus VMs. We've talked about container orchestration. We've looked at nodes, worker nodes, and master node. We've talked about what a cluster looks like. We've talked about Kubernetes in itself. We talked about pods, replica set, deployment, services, ingress, config map, and secrets. This list actually comprises of the basic introduction to Kubernetes. Thank you very much. Thank you for listening. Any questions?